Let's begin. So good afternoon and welcome to this Lunch and Learn webinar from the Supply Chain Sustainability School. Lunch and Learn webinars are sessions where we invite an industry expert to talk about some topic of particular interest to our audience. And today, our guest speaker is John Hanscom from Akerlof, who's now waving at you on screen. And John will be talking about reducing carbon in concrete. So before we get started, I'd like just to establish a few ground rules. This is a very large attendance today, so unfortunately we can't invite you to switch on cameras and microphones. However, I would invite you to use the Q&A facility, which you'll find on the Zoom toolbar, I think at the bottom of your screen. So if you've got some questions for John, please drop them into the Q&A box. We'll allow plenty of time at the end of the session to allow John to answer as many of your questions as he can. And I'm sure if we do run out of time, we'll work and try and follow up with you on any unanswered questions. We will in a moment or two be using an online polling tool called Menti. So ordinarily we'd rather like you to put down your mobile phones while the session's running. But in this case, if you can get your phone ready and using a browser on your phone, go to menti.com, MENTI.com, and you should find in the chat there is an 8-digit code which will enable you to participate in a few fun questions before the session begins. However, just to set the scene, as it were, we're going to talk about decarbonising concrete today. And of course, concrete is actually the most used construction material in the world. However, according to the European Commission, from a sustainability perspective, the amount of raw material used in construction for creating and operating the built environment is argued to be more than any other sector. We therefore consume a significant amount of natural resources. So if we are aiming to become a more sustainable industry that's moving towards net carbon, clearly concrete is one of those materials that we really need to pay some attention to. And John's going to show some fascinating information about how we can actually make carbon a far more sustainable, friendly material. However, before we do that, I think my colleague Naomi is now going to encourage you to go to menti.com, and she will share her screen, I hope, to show you the questions. And if you're struggling again with the code, it's now on screen. I see that a number of you have already managed to grapple with the technology, which I'm very pleased about. So this is just to find out your roles and responsibilities at work. So you can see that most of you are consultants. Good to see some subcontractors in the room, procurement specialists, no cost consultants, which is quite interesting. And some clients, that's always good to see clients, and some designers as well. So thank you. I think we've got another question. Oh, a QS, thank you,
Yes.
sir or madam. We'll try and identify you later. And another designer. Okay, that's still coming, answer's still coming through. Okay, great. More than 50 of you on the call, that's great. And again, number of clients is increasing. Really pleased to see clients taking an interest in these sessions. So Naomi, if you wouldn't mind showing the next question, please. So when you are talking about carbon in concrete and structures, how confident are you on this topic? Somebody very quickly said they're confident, that's great. One person leading the industry on this subject, that's great. Look forward to your comments and questions.
About questions, Dale, we're hoping they'll give us some of the answers.
Okay, so a modicum of knowledge up to expertise, with some people actually saying they don't know where to start. So I've seen John's materials. I'm sure there'll be something for everybody in this presentation today. So I think we have a third question, Naomi, if you would please. So cement equates to about 10 to 15% of the weight of the material within a cubic meter. But what percentage of that, what percentage does it represent of its carbon content? People clearly taking some time to think about this one. So the majority of people falling down in the sort of 2/3 to 3/4 range, I would guess. And I'm sure John will give us the correct answer shortly. And I think we have a fourth and final question, Naomi. Thank you. So an average cubic meter of structural concrete creates 410 kilograms of CO2. How far could you fly using the same amount of carbon? I think if I was answering this quiz, I'd be looking for the I don't know option. Okay, so broad spread of answers on that, John. And I think, is that your final pre-session question, John?
That is that's final pre-session question. I think in that regard, quite a broad range of responses. Obviously, quite different distances. Moscow is the correct answer. So I think the takeaway for me from that one is really it's important to be able to visualize the impact your decisions are having and where carbon sits within the overall piece, which we will come on to. But if I can just share my screen.
Now, audience, if we were in a live environment rather than a virtual room, I'm sure the words John Hanscom at this moment will create rapturous and spontaneous applause, but we'll take that item as read and I'll introduce you to John Hanscom from ACL.
Thank you all. Thanks, Dave. And yeah, we'll never know the answer to that question, that statement, will we? But we'll move on. So I want to talk to you today about reducing carbon in concrete. I think Dave kindly described me as an industry expert. It's certainly not how I describe myself, but I'm going to talk you through today both the route map from reducing carbon and some insight that we've gained, which hopefully will give you food for thought. So I'm John Hanscom. I'm a partner at ACLOF who specialise in modern methods of construction, sustainability, and effectively working with organisations to drive better outcomes within the built environment. As part of that role, I led a project which is funded by Innovate UK, looking at the decarbonisation of precast concrete, and many of the lessons that we learned through that study apply to both precast and in situ concrete. So why are you here? Is to hopefully learn about the Green Construction Board's low carbon concrete routemap and what it means. There's some pretty bold statements of what we're looking to achieve around best practice in concrete manufacturing, embodied carbon reduction, how to design and specify and reduce carbon impact from concrete, and the benefits of carbon sequestration within concrete and new technologies. Quite a broad set of subjects to cover in 20 minutes. Pretty much guarantee you won't be experts by the end of it, but hopefully you'll have some takeaways that you can use in your everyday work. So low carbon concrete routemap produced by the Green Construction Board's low carbon concrete group, which is built up of 41 experts from across the industry who've contributed to the routemap. It's been peer reviewed by 23 individuals, and those contributors and reviewers come from a broad range of organisations, or broad range of backgrounds and expertise. So it's a pretty well developed route map and looks at the use of concrete and how to reduce carbon from a broad range of angles. I think just a note from Andrew Mulholland, who is the chair, is that really the route map is a good guide to some really good ideas, but equally sets out a strategy and a set of strands and signposts for continual improvement in both technology, available materials, skills, knowledge, and approaches to design. So the route map is a starting point for this journey rather than the end of the journey. And why is this important? I think Dave touched on this, because our use of cement within the UK is significant, and whilst concrete is a very agile material, has very good design life, it's good for structural strength, acoustics, fire, so has many positives. It has a real Achilles heel, which is carbon, and so we need to find ways to drive out that carbon intensity both within concrete and use concrete more wisely to reduce its overall usage. So to give some comparators, our use of concrete within the UK is equivalent of somewhere between 7 and 8 million cars on our roads every year. So the low carbon concrete route map is broken into 2 parts, 7 strands. So using concrete and making concrete. So using concrete looks at knowledge transfer, how we share knowledge across the industry, how using standards can broaden knowledge, and how some of the tools are both available now but are also being developed. The role of design and specification, both in the concrete mix but all equally in that use of concrete and getting the most for every cube of concrete we use. Supply and construction, so how we think about how we use concrete, whether that's through precasting, whether that's through better use of temporary state of works in the final design, and collaboration across the supply chain to drive out carbon. Optimizing existing technologies. So one of the things that certainly we found from our research is actually a lot of the answers to reduce carbon significantly already exist within the marketplace. And so actually bringing those together, combining them, how we think about design and concrete mixes, taking some academic work, and there's a lot of academic work in this area, and those existing technologies and deploying them on a broader scale can have instant wins, and quite significant wins. Adoption of new technology. So when is it appropriate to adopt new technology? How should new technology be adopted? And then carbon sequestration, capture and use. So the work that is going in, significant work that is going into how concrete can be used to capture carbon, and its role in that sequence. So what the route map does well is equally set out for each of those 7 categories, where we are today, where we'd like to get to by 2030, to ensure that we can hit our targets, the steps that need to be taken, which are both practical, governance, and through digital tools. So the use of BIM, the use of AI are all covered within the route map. I won't go through each box, because one thing I would recommend you all to do is to read the route map and ponder the relevant sections in your own time. What I'd like to talk further about is some of the detail and pull out some of the salient points within that, and how they might relate to your day-to-day activity. So we asked the question on Menti of how much cement was in a cube of concrete, and the majority of people underestimated that question. So 87% of the carbon within a cube of concrete, bearing in mind it relates to 10 to 15% of its volume, comes from comes from cement. So on the left-hand side, that is a raw cube of concrete. On the right-hand side is a more rounded wheel, which shows both the concrete, but equally within most structures, concrete is reinforced, and reinforcement also has a significant impact within the overall structural elements of a cube of concrete. So beyond the actual wet cube of concrete, reinforcement equally has a particularly poor carbon outlook. And actually, when you look at so this wheel basically takes you through full life cycle, the impact of other elements is relatively small. So transport and batching, for instance, 6%. Activity on site is generally 2 or 3%. So it's great that we were using electrical vehicles and electric cranes and all these things, but actually to make a real difference, reducing the cement content and reducing the overall use of concrete is where the real gains made, significant gains. Albeit we need to take that journey from all fronts. So not to dismiss the use of electrical vehicles, because it's really important, but the bigger gains are made within the use of cement and reinforcement. So where to start? So to start, I would always suggest measurement. So calculating where your embedded carbon sits within your product or within your project. Referring to EPDs. So EPDs are the environmental product declaration, which is a prescribed route under ISO 14025 to determine the environmental impact of a product. The one warning or caveat I'll give to that is they're a declaration, and so some of those declarations are maybe not as genuine as should be, and so review them with a level of skepticism, but actually they're equally as good a starting point as any other, and they feed into the LCA tools and life cycle assessments. Over time, we're starting to see some really good examples of rating certificates, and this is talked about within the Routemap, and hopefully we can push and see more use of energy certificates, because really, as much as anything, graphically they simplify the message. Becomes much easier to rapidly compare different solutions, and so whilst they're not widely used, one of the things I would encourage is people starting to use certificated ratings that are genuine and can be used to compare different products and different solutions. But certainly at this point in time, EPDs are by far the best place to look at environmental impact. And on the left-hand side of the screen, the Institute of Structural Engineers Guide to Calculating Embedded Carbon is a really good starting point for how to measure carbon within products and projects. So the other thing that is really important, this is whether you are a manufacturer, a subcontractor, a client, or play any part in development of a built asset, is really to map the carbon within your solutions, in your buildings, and visualize where that carbon sits and what you can do about it. So many marginal gains makes a big difference. This is a mapping for precast, but it applies to in situ as well. And by mapping that carbon impact, you can start to look at decisions that are affecting that use of that carbon, and whether that is the best use of carbon in your overall scheme of product. So that's looking at the process, looking at buildings, identifying carbon. So in a typical building structure, about 50% of the volume of concrete and reinforcement goes into floor slabs, 20% in foundations, 20% into lateral stability, so cores or shear walls, and then 10% in columns and other walls. In areas such as lateral stability, you will have generally a much higher reinforcement content, and equally, quite often you have a much higher mix strength, which generally our mix strengths require quite more cement. And so looking at your buildings and your structures in a way that you attack the biggest volumes to reduce carbon is the way to go about it. So floor slabs is often an area where we would recommend that you start first. And I think the routemap points out quite well that just reducing your grid from say 9 meters to 7.5 meters, whilst that's 17% reduction in span, will give you at least a 20% saving in overall carbon within that structure, makes that use of carbon concrete and reinforcement much more, gets much more use out of it, so in its strength. Equally, a common grid, so a regular grid, taking loads down straight paths, delivers significant carbon savings. So structures that are offset, transfer slabs, cantilever structures, the carbon content to do those things increases rapidly because of the amount of structural elements that you need to support the building. So in looking at carbon thinking for floor slabs, so taking those are the biggest areas, there's a number of levers that you can pull to optimize the amount of concrete you're using, the type of concrete you're using. So interrogating loadings. So what are those loadings? Are they just cut and paste from the previous project? Are they relevant to this scheme? How can we reduce them? What are the factors of safety that we're relying on in those loadings? Establishing the design life. So what's the optimum design life for the structure? Is it 60 years? Is it 120 years? Is it shorter? Actually, that design life calculation has very little effect in the embedded carbon, but when you challenge your embedded carbon along across the overall design life, then sometimes by increasing the amount of carbon slightly at the early stage to give a better design life, give a longer design life, it's actually better in the long run. Optimize component size, so whether it's precast or in situ, what is the optimum size for spans for units to get the most out of concrete and reinforcement. Mixed strength using design calculations. So this one for me is around ensuring that your temporary state works and your mixed design using your design calculations are aligned. So there's no point a designer specifying say a C40 mix and basing his rebar calculations on that design mix if for productivity purposes within precast or schedule purposes within in situ or for temporary works, that mix is going to get strengthened. So to increase speed of curing, for instance, it's not unusual for that mix to get additional cement added to it to increase that speed of curing. That might be required by the schedule, but if you put that back into the design, then you can start to play around with element thickness, you can start to play around with reinforcement content if that strength. So the worst thing that can happen is you specify lower strength, you get a higher strength, and you don't take benefit of that higher strength. That's a lose-lose situation. Looking at the component thickness and the rebar content and the balance of those two, what is the optimum? Voiding of areas, so where you've got redundant areas in the structure, how can they be voided to use less concrete? And really thinking around the impact of builders' work, making sure that builders' work, where possibly, set in the right places to minimise structural load and thus increase reinforcement content. By doing all that, you should be able to reduce the volume of concrete. And the way I look at it, if you reduce the volume of concrete, the cheapest cube of concrete is the one that you don't buy. You can reinvest that money in some really good mixes, which again will bring down the carbon content of the overall. So reduce and then reduce the impact. On the left-hand side, another really good tool for designers and engineers is to use with your clients is to look at the carbon heat mapping of structures. and look at what decisions affect that carbon impact. So moving on to performance requirements, touched on floor loads earlier. What are those loads? Are they required? Are they representative of the use of the building? Some pretty small numbers from 0.54 to 3.10 on this scale, but actually in terms of carbon and reinforcement and concrete elements, they are big shifts, they are big numbers. So what are the floor loadings? Mechanical electrical plant, for instance, is generally getting lighter, it's getting smaller. How is that reflected in your design loads? Or are we just taking design loads that we used historically and not giving that thought? So we're looking at optimizing design loads can have a big impact on reducing the overall volume of concrete and the reinforcement. From an architectural point of view, two brilliant buildings here, really great. One is university building not far from my home. I used to walk past it and think that canopy is really impressive. It's 4 stories high. It spans out about 7 to 8 meters. I'll now look at it and think there's a lot of carbon in that. Was it really necessary? Was it really worthwhile? Does it add value to the building? And I think when you're making decisions around architecture, you know, I'm not saying we should have all completely boring buildings club. I'm a fan of architecture, love architecture, but equally bringing that carbon question into decision making, I think is really important, because these are things really needed when they've got such a large carbon impact. The same with cantilever structures. Cantilever structures, to their carbon to usable square footage are really inefficient in the way they work. Some are necessary, some wonder of the world is required, but do you understand the impact of that decision it's having, and is that an impact you are prepared to have? So both through structural load, but equally architectural decision making, I think it's really important to try and visualize the amount of carbon that decision is creating and whether it's justified and required. So when looking at collaboration, I think the industry is doing a huge amount of research and development of solutions. Often that is quite siloed. So material manufacturers, cement manufacturers are running that research around their manufacturing processes, designers around their design processes, precast manufacturers and concrete manufacturers are doing it around their elements, and then builders and specialists are doing it around their elements. And whilst that focus is valuable, what it really gives is an area of missed opportunity. So one thing the Routemap really encourages, and we would definitely encourage, is collaboration across the supply chain, sharing wider industry knowledge beyond the bounds of your peers, understanding each other's waste. So can you use redundant strength, for instance, in temporary works back into the design? Greater understanding of the standards and how the standards can help you define what good looks like. That sharing of data, deployment of academic research from the start of raw materials through to the installation process, and understanding and sharing everyone's impacts so that we can all learn from each other and come up with better solutions. So that collaboration, optimize, test and refine, we think is really important to making some pretty significant gains. Touched on it, use temporary work strength. So if you've got design strength at say C35, C45, actually you're making it at C65, 75 for that temporary works purpose, whether that's stripping molds, whether that's for any other reason. How can you use that back in design? So can you use less reinforcement? Can you use thinner elements, more or less cement? So playing around with that graphical equalizer to get the right balance, and making sure that in those silos we're not making individual decisions that we're not getting the benefit of waste that occurs further on down the path. So another thing to be aware of is that different cement types are never the same. So there's a variable carbon content within each of the prescribed cement types under BS 850, 500. And so again, when stipulating mixed designs, always aim to use the cement type with the lowest possible embodied carbon that suits your need. And again, in terms of replacement, so whilst GGBS and fly ash are generally the most used replacements, their availability will become ever more limited. Their waste from industrial process, and so moving away from those elements over time will be required. But equally, when using replacements, as much as possible in the first instance, but understand its impact on curing times and optimise delivery balance results. So there's a lot of work in this area academically, and I think one of the things I'd suggest to you all is to keep an eye on what's coming. There's lots of new technologies coming, and what gets said today might be completely overwritten in 12 months, 2 years time. So what you think you know, you might be correct today, but it might not be correct tomorrow or the day after. Material sourcing. So one for the specialists and contractors in the room. Not all cements are the same. When we did our research, the biggest variant in carbon was reinforcement. So reinforcement coming from various parts of the world has different recycled content, gets manufactured in different ways, and so across your material supplies, you can have quite varying carbon content in each raw element that makes up a cube of concrete. It's really important that both setting standards in specification, setting standards through procurement, and maximum CO2 levels within each element, we think is really important, and we'd like to see more of, and equally sourcing the materials from sustainable sources. So making sure that all the materials that have been used are sourced from the most sustainable source, and things like aggregates, heavy elements are sourced locally, and ideally are recycled to drive down that carbon content. So we will touch on TRLs and CRLs. So we are in a high level of innovation within this sector at the moment, and that innovation is imperative to carbon reduction, but equally understanding the right time and place to apply it is also imperative, because what we can't really afford is too many failures in this area. It'll dampen enthusiasm for long-lasting adoption. So when using novel or new ideas to you or your organisation, just be really understanding of how technical ready a solution is, what risk, if it's not commonplace to be used, what risk that brings to your project, and are you in the right place to manage that risk. So technical readiness levels, TRLs, is a framework that allows you to undertake that assessment. And then commercial readiness levels is a framework that allows you to assess the commercial readiness of solutions. So the routemap talks about that in more detail, but it's something that I would encourage people to apply, particularly on projects, to when they're looking at novel solutions, to understand how ready something is for adoption, and in adopting it, what risk that is putting you at. And that's not to discourage people, it's just to make sure it's done in a considered and an orderly way. Carbon sequestration is the process of storing carbon in a carbon pool. And really, when you look at, for instance, the UK concrete and cement industry routemap, that they talk about the biggest saving for carbon reduction coming through this purpose. So they're reaching a zero or beyond, as looking at 61% reduction in this area. So it's really important to the industry. It's a developing set of technologies and effectively captures carbon at various points in the manufacturing process, and sometimes locks it back into the concrete. There's a really good case study within the Routemap around Ceretex combining carbon dioxide with livine and widely available natural rock to form silica, which then can be used in SCM instead of things like GGBS or fly ash. And so those technologies are definitely coming onto the market. They are game changing in carbon reduction. Generally aren't quite technically ready at the moment, but I think over the next few years, relatively quickly, we'll start to see products coming onto the market that enable that. Equally, there's lots already available, lots of things already available to be done to reduce carbon within our structures without waiting for far-reaching technologies.
Thank you, John. Really interesting, and a few things that struck me immediately, which I'll go through in a moment. Meanwhile, just to reiterate to the audience, if you've got any questions you'd like John to answer, use the Q&A button at the bottom of your Zoom screen, and we'll try and answer some of those for you. I think my first comment, John, you said it was Innovate UK funded project, and I remember being involved in an Innovate UK funded project myself a few years ago, and I'm really encouraged that we have that resource, that funding from the government that enables us to do this kind of research in an industry that, let's face it, is somewhat inefficient and has scope for improvement in so many areas. So that was really interesting. Could you tell me who some of the other participants in your team were, as it were?
Yeah, so we worked, our sponsor was the Ministry of Justice. We worked with precast company called Forterra, and a design and installing company called PCE, and we were supported by Curtains Engineers and a company called XLR, who did sort of life cycle review for us. So we worked with quite a broad range of organisations to run that project, and the idea was to have the value chain involved to look at carbon, every decision that was made in the process through the lens of carbon, and in doing so, without really using anything particularly novel, we were able to reduce carbon by 40%.
Excellent, thank you. And I noticed at the start you talked about 1.2% of GHG emissions in the UK were due to cement. I've been doing some research of my own, which slightly overlaps on yours, and the worldwide figure I've read is something like 5%. So maybe this isn't even being a problem than we thought. I'll turn to the audience questions. Anna A is the first one. What are the equivalent conclusions about the concrete used for non-building construction?
I'm not sure I get the question, to be honest, but whether it's concrete used for non-building or whether it's concrete used for any other purpose, its carbon content is broadly the same. So the conclusion is that concrete has a lot of carbon, and we should minimise its use and look to use it as efficiently as possible.
Okay.
Not sure that was the essence of the question, really, but yeah.
How are standards developing? This is from Glasgow Kings Park Congregation. How are standards developing to allow the use of OPC and rebar alternatives, AACMs, basalt bars, etc.?
So those standards are, from my understanding, it's not an area I'll particularly proclaim great expertise in. My understanding is those standards are developing. One thing we require from people involved is to encourage that development. I think standards become new when there's an interest, and making sure that people are aware there is an interest is really important to push the bodies that develop the standards to do so. So, yep. You know, and I think a route for doing that is through the Low Carbon Concrete Council of the ICE and their details within the report. So, but I think development of new standards to use new materials and feeding that back into all the way through the standards is really important.
Yeah, thank you. Next question, and this is really interesting, and I'm not sure any of us can answer this. What happens to the mix design when the substitute materials run out over the years?
Well, the danger of that, and luckily I think there is a lot of development in new substitute materials, so that's good as an area of focus. If it runs out, we end up going back to OPC and more cement, I'd imagine, potential alternative materials. But I think the reality of life is concrete is here to stay. So finding new replacement materials is critically important. Equally, in the short term, in the medium term, that those materials are available and should be used, because we can make a big difference now rather than waiting for what comes in the future.
Yeah, I think there's a phrase about necessity being the mother of invention, isn't there?
It is, and yeah, so.
Okay, next one. Should clients be mirroring the ICE Routemap to increase awareness within their supply chain?
Yeah, totally. So I think I'll totally advocate that, and beyond the supply chain, really, I think within their own organisation. So having a clear route map for their assets, how they intend to reduce carbon, what they require from their supply chain in doing so, where they're going to invest, where they're going to share knowledge and increase learning. Then yeah, I'm a real big advocate of organisations doing that, because I think it's easy to say it's someone else's responsibility, it's industry, it's government, but actually organisations taking a grip of it themselves, for me, is how we'll get far more done. Yeah.
And incidentally, just a reminder, I think Naomi had dropped a link to the route map in the chat earlier on today. So next one, from a client perspective, any advice for driving to drive low carbon concrete through the supply chain? Most new products in the market are costly and don't fit to lowest whole life cost delivery model.
So I think, so there's yeah, hopefully through the presentation we covered some of that. So I think specifying it in the first instance, specifying sustainable rebar sourcing, specifying so mixes. Equally, the first area for any client for me is looking at things like grid and their loadings, their specifications, their performance requirements to reduce the overall requirement for concrete. So in my simple mind, if you've got a building that's got 5,000 cubic concrete in it, and you can drive out 10% of that's 500 cubic concrete you haven't got to buy, and you can redeploy that money towards more novel mixes, and look at it that way. So trying to engineer out concrete in the first place, and then using that saving to increase the carbon efficiency of your mix.
I love the expression you use. I wrote it down: the cheapest cubic meter is the one you don't buy, which I thought was encapsulated the issue.
It's the cheapest to the greenest. It applies to electric, it applies to concrete, it applies to steel.
Yeah.
So, if you work off that basis in the first instance, then you can then choose to spend that money elsewhere if you want to, or you can take the saving. But both are good for you, both good for the planet.
Have you found any cases where any use cases where an entirely different material could be used instead of concrete?
Yeah, I think there's loads of good use cases in this area. I think some of the timber structures can definitely use concrete. Concrete isn't the only show in town. The use of an area I'm quite passionate about is use of composite materials, so combining timber and steel and concrete and other more novel materials together to get more efficient use of those materials. There's some really good use cases around composite structures. People like B&K Structures, to be fair, in the marketplace. People like PCE, doing some pretty impressive things. So it doesn't always have to be an entire shift. I think you can shift components and so on and so forth. So but again, that comes back to me to understanding where carbon sits within your overall project, where carbon sits within your overall decision making, and then looking at solutions that might bring that down.
Thank you. A question from Tim Brentnell. For a consultant developing nuclear decommissioning approaches, which won't be delivered for several decades, what's a sensible target below the current 400 kilograms of CO2 per cube?
It depends where they're going to do it. I'd like to say 0, but I don't suppose that's a great answer. I'm not too sure, to be honest. Yeah, I think you've got to aim. I think the one thing in nuclear environments that you would need to ask yourself to set that target is how prepared am I to use such critical infrastructure for novel solutions. So I'm pretty sure carbon capture solutions are around the corner and will be markedly available in the next 5 to 10 years, and some are coming to market already. And that technical readiness, how prepared you are to deployment in that scenario. And I think by making that decision will then determine what a sensible target is.
Thank you. Another question.
I'll push that question, but
has there been any collaboration with the Ellen MacArthur Foundation for this research?
I don't know, to be honest. So I was a peer reviewer of the overall routemap. So I'm not too sure. I can happily find out.
Okay, we'll come back to you on that one. Can you give us some example companies, organisations working on SCMs other than GGBS and PFA?
Yeah, so within the routemap, there's a couple of good case studies. Probably a name you wouldn't expect to mention, but Saudi Aramco is equally an organisation who are invested heavily in this area, and some of the larger energy companies are happily circulate around the list of half dozen organisations after the workshop. But yeah, there's a few,
okay,
and then a few of them are well backed, so will hopefully make a difference relatively quickly.
Excellent, thank you. Next question, any thoughts on graphene enhanced asphalt to improve structural performance, reduce slab thickness and the quantity of rebar used?
I think at the moment it's probably not commercially viable, but I think over time will become so. So yeah, I think it's definitely a solution to watch out for, like many others, and it'd be interesting to see how some of the sort of working SCMs and the working graphene and all combine to and structural form and the use of BIM in terms of structural form combine to really make a difference. And so I think there's definitely a place for a lot of these new technologies, but getting to that commercial readiness is probably the biggest hurdle. I think the technology in a lot of these areas is there or thereabouts. So there would definitely a place. It's timing on that. That goes back to my comment within the presentation, really about what is true today. I don't think will be true in 5 years' time. I think keeping an eye on the market, on research is really important to make sure that at the earliest opportunity we're mass adopting the right solutions.
Yeah, I think I was going to reflect that earlier comment you made back to you, that what might not be viable now, ask again in 2 years could very well be.
Yeah, totally.
Thank you. A comment from Paul Hickey. It's a very valid point about the one you don't use, ... Consumption in general depletes natural resources and drives carbon emissions. We need to simplify. So I think that's a voice in support, a comment rather than a question. John?
Yeah, I think, when we looked at it, I was really surprised how much a common grid without transfer, without cantilever, what effect that had on carbon. It's quite staggering, and often sometimes we had transfers for really good reasons, but quite often we had them for aesthetic reasons, and you've got to ask yourself the question if that is now the right answer.
Yeah. Thank you. From an anonymous attendee, as a client, we're trialing AACM, alternative rebars, etc., in real construction situations. Where would be the best place to share our findings and experience? Do you mind if I answer that one?
Yeah.
Well, one of them is through the school anonymous attendee. We're very happy to showcase innovations and examples of successful projects through events like this type of webinar or simple uploaded printed case studies or similar. So if there's something you feel you can offer to the industry, I'd be very happy to have a conversation with you. Is there anything you wanted to add to that, John?
Yeah, I think there's probably three places I'd head. One is definitely the school. The other is the Green Building Council. So the Green Building Council on their website capture some new solutions for different building types. So I'd definitely approach them and submit case studies to them guys. And then again, the ICE and the Carbon Concrete group, I would definitely reach out to those guys, because across those three bodies, those three organisations, they've got really good coverage. I suppose the other one, actually the fourth of me, is Letty in London, who do some really good work in this area as well.
Just as an idea, is Innovate UK open to further research in this area?
That's probably a question for them, but I think anything to do with carbon and increasing productivity, they're quite often interested. Keeping your eye out for different funding rounds. You can log onto their website and get a regular newsletter. And we found Innovate UK funding was really, really helpful, because what it allowed us to do was to set the project up solely focused on the outcome of reducing carbon, rather than trying to do it through the life cycle of a project, which, as you will know, Dave, once the project comes under pressure, innovation often gets watered down. So that Innovate UK funding allowed that project to run as the project. I
don't think I've ever read a research project that didn't conclude that more research is needed. So maybe worth an approach to them. Question from Tom Williams. In your opinion, over time, will other products be used in replacement of concrete, or will concrete always be used with greener alternatives and used more efficiently?
I think there's a place for both. So I think a broader range of materials is really important. So go back to that point of using more composite materials. I think probably within my lifetime, the concrete will always be used. It's so embedded in our society, so embedded in our thoughts. It's relatively cheap around the world. It's really malleable, and so I think, whether it's right or wrong, that's what will happen. And so reducing its carbon impact now by taking what's available, for me, is really important.
Okay, thank you. And another question from an anonymous attendee. What, in your view, is the definition of low carbon concrete? There seems to be quite a lot about a debate about what counts as low carbon and what doesn't.
So that's a really good question. And I think that number should always be falling. So what is good today won't be good tomorrow. It depends on the circumstances in which you're using it. So things like CEM3 are really good solutions, have a really low carbon content, but are applicable to certain scenarios. So what is good for one element of structure is not good for another element of structure. And so I'll probably dodge that question as well. But
I think another audience member has contributed to that thought. Anonymous attendee says that 30 or 50% GGBS is low carbon concrete in comparison to 100% OPC. It all depends where you start your carbon count from, which I think encapsulates it quite well. So thank you for that comment.
Go with that. I think, and equally that looks at the concrete you are using, and the first step is going to be to reduce the amount of concrete.
From wherever you are. We'll get through the last couple of questions. Are there any expected changes in CCU concrete strength?
CCU. I'm not sure I get the question, to be honest.
We don't know is the answer, I think, then. Kavita Ramchandra, hi, thanks for this interesting session. Could you please share any thoughts in regards to the use of low carbon concrete in MMC? I'm curious that whether there are any studies in the public domain regarding MMC that you could share.
Well, funny enough, so we'll share. We did a research into use of reducing carbon within precast, so that definitely a form of MMC. And so there's some good good studies around that. I think Ty did some studies around the tower label using volumetric into carbon use in there. But yeah, many of the rules that apply to whether you're doing MMC or traditional build, they're still the same. So the only thing you need to look at with MMC is what's required for the manufacturing process over and above the design process. And how you use that back into the design process.
Going to make this the last question because we are running short of time, from Eric Mackey-Kern. As an end user organisation which commissions the provision of infrastructure assets in the environmental protection domain, we inevitably require concrete or equivalent in solutions, but we're keen to design out carbon as early as possible in the optioneering stages. Do you have any advice on how clients can improve statements of requirements to allow for more decarbonisation innovation in the supply chain?
So I think for me, it's about firstly understanding where you create that carbon, looking as an organisation about what is available, what is achievable, and then making sure that's specified in the first instance. And then working, if you've got a long-term supply chain, which I hope you have, is then setting KPIs and targets of how you reduce that carbon for those designs. So setting benchmarks, setting clear specifications that require those possible use of carbon, and then working back from there. So again, comes back to one of the early questions about setting that route map, but being really clear with your supply chain about that route map, but equally making it contracted. So make it a performance requirement. And as I say, go back to the point about rebar, we all looked at cement. Actually, the biggest differential in carbon content for material supply was in reinforcement. And so assuming that your reinforcement is coming from the most sustainable source, for me, is not a great starting point, which often organisations do whilst they're talking about more novel solutions. And actually, there's some really quick wins in ensuring that things are specified correctly to current standards.
I think for me, I'm getting the sense that you and I have worked in the offsite and MMC sector as well, and I think in that area we recommend early engagement, close collaboration, etc. And what's striking me is that those are exactly the same techniques, perhaps, that need to be adopted to decarbonise concrete.
Put the slide up on before. It's about going away from linear supply chains that look at everything in isolation to getting people to work together to come up with better solutions.
I'm going to ask you two more questions. One question requires a yes or a no answer, and the second one you can go a bit further. So, Anonymous, do you think the carbon efficiency will ever overcome the price point?
Yeah.
And the final one, and this is really intriguing, if cement was produced using renewable power, how would concrete rank in terms of carbon use?
Still be pretty bad. So the manufacturing process itself creates a bit of carbon, so it's not just the energy requirement. Okay. And I think
thank you, John.
In the concrete, from memory, in the cement and concrete roadmap, it talks about the efficiency of renewable energy in its production, and I think it's about 4 or 5%. So it's not massive. Okay.
We need to draw the session to a close. It's 1 minute left. So I'd like to thank John Hanscom from Akerlof. I'd like to thank all the audience members who asked questions. It's been an extraordinarily large audience, which indicates to me there's a great deal of interest about this in the industry. So thank you so much for joining this Lunch and Learn session. Please watch the Supply Chain School's website, the events page for future webinars. This recording will be uploaded as a resource as soon as being edited. And finally, when the Zoom session closes, you'll also automatically be directed to a feedback form. We'd really appreciate you taking 2 minutes just to complete that form on our behalf. So with final thanks once again to John Hanscom of Akerlof, this event is closed. Thank you and goodbye.
Thank you all.